They made it home. Splashdown confirmed. April 10th, 2026. Pacific Ocean off San Diego. Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen are alive and on the ground. The first humans to leave Earth orbit in 53 years completed their mission and returned safely. And NASA's associate administrator stood in front of cameras and said the words everyone in the program had been waiting years to hear. The path to the lunar surface is open. That's the headline. Here's what's underneath it. Right now, the Orion capsule is on a Navy ship heading back to Kennedy Space Center. When it arrives, engineers will begin a 30-day inspection that will determine whether the next mission, the one that actually puts humans on the moon, can fly on schedule. Because Artemis II didn't just test whether 4 people could survive a trip around the moon and come home. It was the mission that was supposed to close 4 open engineering questions that have been sitting unresolved since the last time NASA put humans on top of a rocket and aimed them at deep space. It closed exactly 0 of them. The mission succeeded. 4 of the most critical problems facing this program are still open files. And the crew flying Artemis III in 2027 is going to inherit every single one of them. Start with the heat shield, because everything else is downstream of it. When Orion came home from the uncrewed Artemis I mission in November 2022, engineers expected to find a heat shield in reasonably good shape. What they found instead was damage at over 100 locations. Large sections of avcoat, the ablative material that protects the crew cabin from plasma at 5,000 degrees Fahrenheit, had cracked and broken away in chunks. Not the controlled, predictable erosion the models had predicted. Unpredictable material loss in locations that the ground testing hadn't flagged, caused by gases building up inside the blocks during re-entry and rupturing through the surface when the pressure exceeded what the material could contain. NASA spent 2 years understanding that failure. By the time they did, the Artemis II capsule was already built, the shield already bonded in place. Replacing it would have cost years, so they changed the re-entry trajectory instead, eliminated the skip maneuver that had triggered the pressure buildup and flew a steeper, more direct descent that kept the heating pattern in a regime where engineers had higher confidence the avcoat would behave. That modified profile flew for the first time with humans aboard last week, and as of right now, nobody knows if it worked. The shield is still on the ship. The inspection hasn't started. NASA's own administrator said publicly that the results will determine whether Artemis III can fly on schedule. That is not a formality. That is the most critical 30-day window in the current phase of this program, and it is happening right now, and the answer is not yet known. Here is the additional problem that doesn't get enough attention. The heat shield flying on Artemis III is not the same design as the one that flew on Artemis II. It's a redesigned version with a more permeable avcoat formulation specifically engineered to avoid the gas pressure problem that caused the original damage. That redesigned shield has never flown. It has been tested in arc jet facilities. It has been modeled extensively. But the only way to know what an ablative heat shield actually does at lunar return velocities is to fly it through an actual lunar return re-entry. And Artemis III will be the first time that version of the shield has ever done that with human beings inside. So the sequence is: fly the original flawed shield on a modified trajectory, inspect it, hope the inspection validates the fix, then fly an entirely new shield design on the mission that carries people to lunar orbit for the first time. 2 untested configurations in 2 consecutive crewed missions, both of them sitting between 4 people and plasma hot enough to melt titanium. That's problem 1. The other 3 don't get nearly as much coverage, which is exactly why they're worth looking at. Throughout the entire 10-day mission, engineers in Houston were monitoring a helium leak in the service module's propulsion system. Not a catastrophic leak, not something that threatened the mission. A small, persistent bleed of helium from a system that uses the gas to pressurize the propellant lines that fire Orion's thrusters. The kind of leak that, on a 10-day mission with a service module that burns up on re-entry anyway, you manage and document and file for future analysis. The analysis is now happening. On Flight Day 8, NASA cancelled a planned manual piloting demonstration, specifically to gather more data on the leak's behavior. That test was part of the mission's evaluation of Orion's manual control capabilities that matter enormously for future missions, where a crew might need to fly their spacecraft independently if something goes wrong far from Earth. It was cancelled not because the leak was getting worse, but because engineers wanted more data before putting additional load on a system that was already showing anomalous behavior. The helium leak is now an open engineering question for every future Orion spacecraft. Where it originated, why it developed, whether it represents a manufacturing issue or a design issue or an isolated anomaly, none of that has been answered yet. And unlike the heat shield, which at least has a known failure mode and a proposed fix, the leak doesn't have a confirmed root cause. Problem 3 is the toilet, and the instinct to treat that as a minor footnote is exactly wrong. The Universal Waste Management System, Orion's onboard waste processing unit, developed a problem during the mission. It couldn't fully vent processed urine into space as designed. The current engineering theory is that a chemical reaction inside the system generated debris that blocked a filter. The original hypothesis, that water ice had formed and blocked the vent, turned out to be incorrect after further analysis. Christina Cook joked during a live downlink about being the mission's space plumber. It landed well. The room laughed. For a 10-day mission where the crew can manage workarounds and mission control can develop contingency procedures in real time, a partially degraded waste system is an inconvenience. For Artemis IV in 2028, the mission that will land 4 people on the lunar surface and keep them there for up to 30 days, a malfunctioning waste management system is a potential mission-ending event. The biological waste generated by 4 people over 30 days in a sealed spacecraft is not an abstraction. It has to go somewhere. The system designed to handle it has now demonstrated an unexplained failure mode on its first crewed deep space mission, and the root cause is still under investigation. The 4th problem is the one with the highest potential consequences and the least public attention. During the mission, a planned demonstration of Orion's radiation shielding capability was cancelled. The specific details of what was cancelled and exactly why have not been fully disclosed, but the context matters enormously. Artemis II launched at solar maximum. Solar cycle 25 is currently at its peak, the Sun at its most active in over a decade. Beyond the Van Allen belt, where the Earth's magnetic field no longer provides protection, a single large solar particle event can deliver a radiation dose in hours that approaches the limits of what human biology can tolerate. The radiation shelter inside Orion is a reinforced corner of the capsule, the most shielded volume available, where the crew can crowd together if a solar storm erupts during transit. Whether that shelter is adequate for a worst-case solar particle event has never been tested with humans aboard. The Artemis II crew spent 10 days in deep space during solar maximum and returned safely. That is a data point. It is not a validation of the shelter's adequacy under the conditions it was designed to handle, because the worst-case conditions did not occur. The Sun was cooperative. It does not have to be. Artemis IV will put 4 people on the lunar surface for 30 days. The south pole of the Moon has no atmosphere, no magnetic field, no protection of any kind between the crew and whatever the Sun decides to do. The spacesuit is the only shield. The habitat, if one is available at that point, provides some shielding. The adequacy of that protection under a major solar particle event is still not fully characterized. So here is where the program actually stands. The path to the lunar surface is open. That statement is true. Artemis II demonstrated that humans can survive a trip around the Moon and come home alive, which was genuinely uncertain 2 weeks ago and is now proven fact. That matters enormously, and the mission deserves the recognition it has received. It is also true that the heat shield results aren't in yet. The helium leak doesn't have a confirmed cause, the waste system failure mode isn't understood, and the radiation shielding has never been tested under worst-case conditions with a crew aboard. Artemis III launches into lunar orbit in approximately 18 months. Artemis IV lands at the South Pole in approximately 2 years. 4 open files, 2 missions, 1 window to close them. Thanks for watching. and I'll see you in the next one.